here is a picture of how much CO2 there is in the atmosphere. Here's 1000 AD. Here's today about 2000 AD. And what you can see is, and these are samples taken from ice cores, not from ocean cores, but ice cores. Very similar technique. And you can see that the CO2 in the atmosphere has remained pretty much the same until after about 1850. And what I want to concentrate on for a minute is this part of this graph. So as a scientist, I like to see this baseline because it tells me where we were. Now let's look at where we're going. Okay, so this is a close-up of that part of the graph. This is atmosphere measured at Mauna Loa, that's Hawaii, the mountain in Hawaii. And they simply have been measuring how much CO2 is in the atmosphere. And this record just starts at 1960, and you can see, it's kind of neat. You can see the photosynthesis, because this wiggle here is winter, when the plants don't photosynthesize very much, and then summer, when they suck the CO2 out of the atmosphere, and then the world breathes in, and the world breathes out, and the world breathes in, and the world breathes out. But what the important thing, and this is just a blow-up of one of those annual cycles, as we call it, but this is the trend. Okay. So CO2 in the atmosphere is definitely going up, but, and we know it's coming from man-made sources, but much of that CO2 is actually missing. And what we can do is we can calculate how much oil, how much coal, how much natural gas is mined, how much is burned, and we know how much should be in the atmosphere. Okay? That's just called calculating a budget. And then we go out and measure it, and what we see is a whole bunch is missing. So this line that we've put on here is the predicted line. If we calculate how much should be there, and if we just started here, because there's a lot more missing than this, but if we just start here, because we know that number, we don't really know how much was burned in the 1850s. But since 1960, we should have a lot more in the ocean. So, I'm sorry, a lot more in the atmosphere. So all of that shaded area is missing. And where it is we know it's in the ocean. And the question is why, and that's what I'm here to tell you. So carbon dioxide goes into the ocean. How do we pump, I'm going to ruin the microphone here, pump all that CO2 into the ocean? And it's the chemistry. It's not just that it dissolves, it also reacts to the water, and it's simple acid-base chemistry. So the CO2 goes into the water, and it reacts with the water, okay? So, and you guys do this with me. What happens is the oxygen really likes hydrogen. So it yanks the hydrogen, oh, yep, next one. It yanks the hydrogen off the water like that. So the carbon dioxide oxygens are a little bit more aggressive. They yank the hydrogen off the water molecule. Then the water molecule is left with nowhere to go. So, and the carbon is left with only 2 bonds. It needs 4. So your carbon, your other oxygen goes on down here. So now what we have is carbonic acid. Okay? And that's your carbonic acid molecule. Okay? There's lots of kinds of acids, all right? Vinegar is a very famous one. It's a mild acid. What an acid is a molecule that's very happy to give away its hydrogen. If you have done even a little bit of chemistry, there's 2 ways they define it. It's either a electron acceptor, or in this case, I think it's easier to visualize it as being a proton donator. So it's very happy to give away its hydrogen. And it's in a soup, right? We're in the water, we're in the ocean, it's a soup. It's got lots of salt in it, okay? The hydrogen is very happy to float away. And that gives us bicarbonate. Okay, that happens very, very easily. Okay? And if the situation is a little bit basic, which I'll come to in a minute, it's very happy to give away its other hydrogen. So now it's floating, it will float around as carbonate. Now I've very carefully made my carbonate look a little bit like a pyramid, and we'll see why in a minute. So what we have is, in the soup, the sea soup, is a family of carbonate molecules. It's really a family, and they interchange very happily. Carbonic acid is a weak acid. It'll give up 1 proton. It's also a diprotic acid, meaning it'll give away 2 hydrogens. So Some of them will be there as carbon dioxide. Some of them will be there as carbonic acid. The big hitter in the ocean is bicarbonate because of the pH, because it's not very acid. And carbonate is also of interest if you, because it reacts to make a solid.